All right, ladies and gentlemen, welcome to 9.2. We are going to talk about reference angles and special angles in the unit circle. Remember, Unit 9 is all about the unit circle. We are going to get a lot of the unit circle um, figured out today. You're going to use the unit circle big time today, so make sure you have your notes ready to go. What we're going to do is we're going to define and identify reference angles. That's going to take us like a minute. And then we're going to use special right triangles way back in geometry days to discover special angles of a unit circle. Then we're going to create the unit circle. You're going to see just the special parts of it, the special angles part of the unit circle is that we're going to worry about today. And then we're going to find exact values of trig functions and angle measures using those special angles. Okay, so lots of stuff to do with the unit circle today, mostly to do with special angles. So first up, reference angles. Reference angles are the measure of an angle from the x-axis. Okay, so main thing, you understand that it's from the x-axis. Okay, so what I'm looking at is the sine of 40 degrees. Okay, so sine of 40 degrees, that's just below halfway between the x and y axis. Remember, it's 90 degrees from 0. So let's do that. We should keep doing that kind of stuff. So remember, this is 90, this is 180. We're gonna deal with both degrees and radians today, so be prepared for that. Let me get the 270 here. And we also have the 360. But remember, we also have 0 as well. Okay, so it plays two parts to that x-axis. So 40 degrees is about halfway between 0 and 90, so a little bit lower than that halfway, maybe like right there. Okay, so that would be a 40-degree angle right here. Okay, and the question is, the reference angle is basically the angle formed with the x-axis. It has to be formed with the x-axis. Okay, so there's your 40. Let me draw the other ones here before we answer these questions. Let's make this next one red. So 180 is all the way down flat. So that would be 140 would be just 40 degrees before that point. So again, just below half right there. That angle would be the 140. Let me mark that angle. So that angle is our 140. And we also have 220. Actually, you know what? Let me make this a little bit cleaner here. So we're going to put this instead. So let's put 40 here to represent this is a 40-degree angle. And let's put 140 over here so that we know that this line is a 140-degree angle. All right, and then also 220. Well, where would 220 be? Well, 220 would be just 40 degrees past 180. So hopefully you're sensing a theme here in terms of 40 degrees. So 40 degrees past 180, so just short of halfway, about there. It's about good. Let's knock that in. There's 220. And of course, 320. So 320 is 40 degrees short of a full 360. So let's go with purple there and draw our line just 40 degrees short of 360. And let's mark that right there as 320. So what I'm going to do now is technically you could go into class calc and you could just calculate these four things. But what we're really trying to point out here is what a reference angle is. So if you were to go into class calc and type these four things in, let's actually do that. Let's go into class calc and type these four things in. So in class calc, we've got sine of 40. We've also got sine of 140. We've got sine of 220. And we've got sine of 320. Look at all those answers. They are the exact same answers except sine of 220 and sine of 320 are negative, but they're the exact same decimal points. Okay, that's not a coincidence. These are all 40 degrees away from the x-axis, and since a reference angle is from the x-axis, that means all of these have a reference angle of 40 degrees. Okay, so all of these angles have a reference angle of 40 degrees because they are all 40 degrees away from the x-axis. So 40 degrees away all around from the x-axis. So a reference angle has to be formed from the x-axis. So all of them have a reference angle of 40 degrees. Okay. All right, so again, the measure is how far is it away from the x-axis. That's the reference angle. So all of these angles, what they have in common, they're all 40-degree reference angles because they're all 40 degrees away from the x-axis. Okay, so we're just going to touch briefly on reference angles here on the types of questions you're going to see on the homework assignment and on the test. So first off, went too far there. Let's back up. So we're going to find each reference angle. So in this picture here, we are asked, what is the reference angle? Well, our angle is 150. So the question is, how far away is it from the closest x-axis? Well, if it's 180 all the way around, then that means we are 30 degrees short of 180. So our reference angle is 30 degrees. All right, what about 100? Let's start off by drawing this. Let's get a visual here. So negative 100, sorry, excuse me, negative 100 degrees. So there's our coordinate plane. Let's get a negative 100 degrees. So we're going negative 90 and 10 more degrees would be about right there. So that would make our angle measure right about there. So how far away are we from the closest x-axis? Well, if we're negative 100 degrees away, we have another 80 degrees left to go. And it would be negative here technically, but when we identify reference angles, we only identify them as positive. So it's a positive 80-degree reference angle, okay? Reference angles are always positive. All right, what about radians? Uh-oh, we got radians now. That doesn't change anything. We talked about radians in the last lesson. So let's draw our coordinate plane again. And let's calculate, or let's draw where about the radians would be. So let's not forget in the radians, if we're going in this direction, we have pi over 2 represents 90 degrees. We've got pi representing 180, 3 pi over 2 representing 270, and 2 pi representing a full revolution. So how far of an angle is 23 pi over 12? Well, that is almost almost one full revolution of 2 pi, because 24 pi over 12 would be 2 pi. So we are just short of 2 pi. We're just short of one full revolution. So just about there. That's just, I mean, give or take, you know, a few radians. But that would be our 23 over 12. That should be probably more like this, but just, you know, for the record. Well, if it's 23 pi over 12 that gets us to that angle, how many more do we have to go to get to 2 full pi? Well, again, 2 full pi is the same thing as 24 pi over 12. That would be a full revolution. So how much more do we have to go? Well, we have just one more pi to go on the top, but we can't change the denominator either. So this would be 1 pi over 12. So our reference angle is 1 pi over 12. That's how close it is to making it to the closest x-axis. 1 pi over 12. All right, so that's how to do reference angles. That's all we're going to do with reference angles today. Now we're going to go into what we call special angles. But before we do that, we need a quick review on special right triangles, okay? So way back in your geometry days, it could have been last year, could have been a couple years ago, we learned about special right triangles, the 30, 60, 90, and the 45, 45, 90. All we really need to know is that the hypotenuse is twice as long as the short leg, okay? The short leg is always opposite the 30-degree angle, okay? The shorter leg is always opposite the 30, and then the longer leg is opposite the 60. That is the length of the short leg times rad 3, okay? So again, short leg is your base. Actually, we should probably look at our hypotenuse as our base right here, because this is what it's going to look like on your upcoming questions here. So our hypotenuse is going to be 1. It's going to be 1. So if a hypotenuse is twice the length of the short leg, then that means the short leg is half the length of the hypotenuse. Well, if the hypotenuse is 1, then the short leg would have to be 1/2. And if we have the short leg is 1/2 and the long leg is whatever the short leg is times rad 3, look what it becomes. 1/2 times rad 3 becomes rad 3 over 2. We need to remember these key features of a 30, 60, 90, okay? The short leg opposite the 30-degree is 1/2. The long leg opposite the 60 is rad 3 over 2, and the hypotenuse is 1. Same concept for a 45, 45, 90. The hypotenuse is 1, and the hypotenuse is whatever the leg is times rad 2. So if we have 1 as our hypotenuse, then we need to get rid of the rad 2. If I know that my hypotenuse is 1, then I need to divide by rad 2 to get the a all by itself, which is the length of the short leg. So if I have 1 over rad 2, we can't have a radical on the bottom of a fraction. So what does that mean to do? We have to multiply both top and bottom by rad 2. We did this in the last lesson as well. So we got to simplify this completely. That leaves us with rad 2 on the top and positive 2 on the bottom. Rad 2 times rad 2 is just a 2. We can't simplify that anymore. So that means the legs of a 45, 45, 90 are rad 2 over 2. Both of them are the same in a 45, 45, 90. All right, that is super important to understand. Know that the hypotenuse is always 1, no matter which kind of triangle it is, because we're talking about the unit circle, which is a radius of 1. Okay, that's where it's going to come into play. Know that the short leg of a 30-60 is 1/2, and the long leg is rad 3 over 2. Know that the legs of a 45, 45, 90 is rad 2 over 2. Okay, that's going to come into play right now. So let us determine all these special angles. So the first thing we're going to do is we're going to create a special right triangle within the unit circle, and we're going to use a 30, 60, 90. So this line right here represents 30 degrees, 30-degree angle in the unit circle. What we're going to do is we're going to create a triangle out of it. So if I create a triangle by just dropping a perpendicular here, we now have a right triangle where this was our 30-degree angle. And if that's 30, then this one has to be 60 by the laws of a triangle, 180 degrees. So we have a 30, 60, 90 triangle. And now we know that the radius of any triangle in the unit circle is 1. So the radius is 1. Oh, sorry, the radius is 1, which means our hypotenuse is 1. So how do we get the other parts of this triangle? Well, we just looked at it in the previous slide. The shorter leg, the opposite of the 30-degree angle, is half of the hypotenuse. So this would be 1/2. And the longer leg is whatever the short leg is times rad 3. Well, we simplified that to rad 3 over 2. So what we need to know for sure is this point right here is the point on the x, rad 3 over 2, and on the y, 1/2. And let us also not forget from the last lesson that these coordinates also mean sine and cosine, or I should say cosine and sine. The x coordinate of all points in the unit circle always represents cosine. The y coordinate always represents sine. So if I'm going to ask you a question, what is the sine of 30 and the cosine of 30? This is what we're going to answer, because the 30-degree angle is the one that we used forming with the reference angle, okay, using the x-axis. So we're using the reference angle to determine the value of cosine and sine at 30 degrees. So if I had to answer the question, what is the value of sine of 30? We look at the y coordinate of the point on the circle, and that y coordinate is 1/2. Okay, what about cosine of 30? Well, the cosine of 30 is rad 3 over 2. What about the tangent though? Okay, the tangent isn't involved in any of this. But remember, last time that we had a lesson in 9.1, we learned that the tangent was the same thing as sine over cosine. Well, if that's the case, then I have to take the value of sine and divide it by the value of cosine. So for tangent of 30 degrees, we're going to have to take each of those values and divide them. Sine on top. So 1/2 divided by rad 3 over 2. Well, we have fractions dividing, which means we need to multiply instead. So this is going to be the same thing as 1/2 times 2 over rad 3. All right, we got some funky stuff going on here. So the 2's are going to cancel out for sure. So know your cross-canceling rules, or you can multiply it out and simplify later. But we end up with 1 over rad 3. We can't have that because you can't have a radical on the bottom of a fraction. So times both the top and the bottom by rad 3, and we end up with rad 3 over 3. So the tangent of 30 degrees is rad 3 over 3. Okay, that's another thing that we're going to memorize at some point. Okay, whew, that was a mouthful right there just for that 30-degree reference angle. Let's do the same thing, but now this time we're going to be doing a 60-degree angle. So let me draw a 60-degree angle and drop down to make the right triangle. So we got 60 degrees here, and we got 30 degrees here. All right, our unit circle is still a radius of 1, so the hypotenuse is still 1, but now the shorter leg is down here at the bottom. It's opposite of the 30, so the shorter leg is now 1/2, and the longer leg is now rad 3 over 2 over here. So what is this coordinate point then? Well, on the x-axis, it's gone 1/2, and on the y-axis, it's gone rad 3 over 2. So it's just the backwards version of the previous circle we just did. So let's answer the questions here of what is the sine of 60 and the cosine of 60. All right, well, the sine of 60, remember the sine is the y coordinate of the point on the circle. So that's rad 3 over 2. Cosine of 60 is the x coordinate of that point on the circle, which is 1/2. And tangent of 60 would be the sine of 60 divided by the cosine of 60. So rad 3 over 2 divided by 1/2, which is the same thing as rad 3 over 2 times 2 over 1. Cancel out the 2's, and all we are left with is rad 3. So the tangent of a 60-degree angle is rad 3. Okay? All right, let's talk about the last special angle that's formed here. I'm going to do it a little bit backwards, though, in a different quadrant, I should say, because it is very possible to get your triangles in different quadrants. Let's say we were going to go 45-degree reference angle, but it's right here, okay? Because you are going to encounter some negatives at some point. So there's our right triangle. We are dealing with a 45-degree reference angle. And that means we're going to have a 45, 45, 90. All right, so in a 45, 45, 90, again, our radius, our hypotenuse is 1. That means the shortcut from the last slide to get to the legs is divide by rad 2 and then simplify. So if I take 1 and divide it by rad 2 and simplify, I get rad 2 over 2. And I also get rad 2 over 2 because a 45, 45, 90 has the same lengths of legs. However, look at this on the coordinate plane point of view. This rad 2 over 2 length is a positive x value. So that's positive rad 2 over 2. However, the y is going down. So this is not a positive rad 2 over 2. This is a negative rad 2 over 2. Okay, so what I did here is I've actually used a negative 45 degrees, which is the same thing as 315 degrees. Okay, so this angle right here, this 45, either represents negative 45 degrees because I'm going in the opposite direction, or it represents 315 because I would go all the way around to get to here, which would be a 315-degree angle. So I'm going to use 315. I could totally use negative 45. That's going to show up as well, but I'm just going to focus on 315. So sine of 315 is the y coordinate. Oh, I forgot to put the coordinate. We got to have the coordinate. The coordinate's right here, and our coordinates are rad 2 over 2 and negative rad 2 over 2. So the y coordinate of our point of intersection on the circle is negative rad 2 over 2. Cosine of that 315-degree angle is the x coordinate of that point of intersection, which is positive rad 2 over 2. What about tangent? Remember, tangent is the same thing as sine divided by cosine. Well, if I have a sine of negative rad 2 over 2 and a cosine of negative rad 2 over 2, I'm dividing something by itself, which comes out to just 1. However, it's a positive and a negative being divided, so it's -1. So the tangent at -45 degrees or 315 degrees is -1. Okay, so these are all special points on a triangle that we are all going to identify. There's positive and negatives in terms of quadrants. Just know that the x and the y always represent cosine and sine. Okay, and these are all formed by special right triangles. All right, here is what it looks like in whole. Okay, this is going to be your best friend for this lesson, this unit, and beyond. Okay, this shows up in all kinds of pre-calculus and trigonometry things. This is a fully identified unit circle. I would memorize this if you can. I mean, you're going to have access to use it on the test. I'm going to give it to you, but writing it down will help you memorize it as well. Notice it has the values of all the coordinates where it intersects on the unit circle given to you here everywhere. It gives you both a degree in degrees and in radians. It gives you the angle measure in both. So it gives you everything. The only thing it doesn't do is give you tangent. Okay. It also doesn't give you the cosecant, secant, and cotangent. So you're going to have to figure that out based on this. But this is what we are going to use for our rest of the lesson today for sure, at least. Okay. So let's go ahead and use this unit circle to find exact values. Okay. So number 4, we're going to do these 4 ones in degree sense. So cosine of 120 degrees. So find 120 degrees. Oops. Here's 120 degrees. So we're focused on this pair right here. The cosine is the x coordinate. So that means it's just -1/2. So that one, easy peasy. Okay. What about the sine of 210? All right, well, let's go locate where 210 is. 210 is here. So we're focused on these ones, and the sine is the y coordinate of that point. So that would be -1/2 as well. All right, what about tangent of 315? Well, let's locate 315. 315 is here. So we're focused here. And we just kind of did this one in the previous example. We are going to take the tangent, which means the sine divided by the cosine. So negative rad2/2 divided by positive rad2/2. That just comes out to -1 because it's the same thing timesing itself. All right, what about the secant of 180? Okay, well, let's find 180. 180 is here. Okay, here's the coordinate points for 180 degrees. Secant is the same thing as 1 over the cosine of 180. So look at the x coordinate of your cosine value of 180. So that means this is the same thing as 1 over the cosine value of -1. So if I got 1 over -1, I just simplify that to be -1. Okay, pretty cool, huh? How it works, like a puzzle. All right. What about radians? That doesn't change. Well, their unit circle has radian measure on it too. So we can go ahead and do radians the same way. So let's start off with number 5, sine of 5 pi over 4. Let's find 5 pi over 4. It is right here. So we're focusing on these coordinates for x and y. We're looking at sine, which is the y coordinate. So that would be negative rad2/2. All right, what about cosine of -2 pi over 3? Okay, be careful here. We're going negative now. So I'm not looking for 2 pi over 3 over here. What I'm looking for is -2 pi over 3. So 2 pi over 3 equates to 120 degrees. We got to go -120 degrees. So going backwards for 300, 120 degrees will get us to 240. So -2/3 pi is actually 4 pi over 3. So we're focused on that point right there. So that means we have an x coordinate of -1/2. So be very careful of your negative radians, your negative degrees. You got to be able to go on your graph negative direction. All right, cotangent of pi over 4. Here is pi over 4. Here is our x and y coordinate. If tangent is sine over cosine, then cotangent would be the reciprocal. It would be cosine over sine. So if cosine is rad2/2 and sine is rad2/2, then that divided by itself is 1. Okay, so cotangent, remember, is the reciprocal of tangent. And if tangent is sine over cosine, then cotangent is cosine over sine. All right, and the last one here, secant of 3 pi over 2. So let's find 3 pi over 2, which is on the y-axis, and those are x and y coordinates that we're using. Secant is the same thing as 1 over cosine. So what is the cosine of 3 pi over 2? That's the same thing as 0, because the x coordinate is 0. So what is 1 over 0? How do we simplify that? It's not 0. This is actually undefined. Okay, whenever you try to divide by 0, you get undefined. It is possible to have an undefined value for one of the trig functions. All right, so that's how we are going to use the unit circle to find exact values. Okay, unit circle to find exact values. All right, let's use exact values again in a table form this time. Okay, so I'm going to have to go back and forth between the unit circle and this one. So first off, all we know is that the degree is 30 degrees. That's it. How do we convert that to radians? Well, I can go back to the unit circle for one thing. Oops. Now let's go forward. That works too. So I can go to the unit circle. So 30 degrees is the same as pi over 6 according to our unit circle table. So 30 degrees is the same thing in radians as pi over 6. All right, well, let's go back to our unit circle again. And what is the sine, cosine, and tangent? Or what is just the sine and the cosine? All we need are those two things, and we can figure out the rest. At 30 degrees, the sine and the cosine are 1/2 and rad 3 over 2 respectively. So cosine is rad 3 over 2, and sine is 1/2. So sine is 1/2, and cosine is rad 3 over 2. Whoops. Get back to my slide. There we go. So sine is 1/2 and cosine is rad 3 over 2. That is all the information we need to fill out the rest of this table. Okay, how do I know that? Well, tangent is the same thing as sine divided by cosine. So what is 1/2 divided by rad 3 over 2? It's the same thing as 1/2 times 2 over rad 3. We can't have the rad 3 on the bottom, and these 2's cancel out when we multiply. So 1 over rad 3 is the same thing as rad 3 over 3. All right, cosecant is the same thing as the reciprocal of sine. The reciprocal of sine. So what I do is I take the sine value of 1/2, flip it over, that's 2 over 1, which is just 2. Secant is the reciprocal of cosine. So what I do with the cosine, 2 over rad 3 over 2, I flip it over to be 2 over rad 3. We cannot have a rad on the bottom, so times both top and bottom by rad 3, and we end up with 2 rad 3 over 3. Nothing else to simplify? Fine, that is our answer. Not pretty, but that is our answer for secant. Cotangent is the reciprocal of tangent. So in that case, if tangent is rad 3 over 3, then I need to flip that over and multiply both the top and the bottom by rad 3, and I get 3 rad 3 over 3. Well, those 3's can cancel out, and all I'm left with is a rad 3 over 1, which is just a rad 3. All right, we're also asked for the negative degree and the negative radian of our degree of 30. So remember, 30 degrees is the exact same thing as negative 330 degrees. All we're gonna do is just minus 360 to get this answer. Okay, if I went negative 330, I would end up at positive 30 degrees. What about negative radians? Well, I would just minus 2 pi from that. If I went pi over 6 minus 2 pi, that's the same thing as 12 pi over 6. So I would get negative 11 pi over 6. So I'm just minusing a full revolution. That's all I'm doing for that negative part. All right, let's try one more like this table here, number 7. So now I'm given the radians. Well, how do I know the radians? If I know the radians, how do I know the degree? Well, go to your unit circle. If radians is 1/2, look at the degree. It's 90, okay? The degree is 90. So radians is 1/2, the degree is 90. So that's what I'm gonna write for my degree. And our coordinate point at 90 is the point 0, 1. So that means the sine of theta is 1, because the y coordinate of that intersection point, and the cosine is 0. If I wanted to find the tangent, sine over cosine, that's 1 over 0. That doesn't exist. That would be undefined. Cosecant is 1 over sine, so 1 over 1 is 1. Secant is 1 over cosine, 1 over 0, undefined. Cotangent is the reciprocal of tangent. Well, if 1 over 0 was tangent, then that means 0 over 1 is cotangent. And that would mean 0. Cotangent, it would be 0. All right, what if I went negative? Well, 90 minus 360 is negative 270. And pi over 2 minus 2 pi would come out to negative 3 pi over 2. All right, so using that unit circle to complete the table. All right, let's do this last question here for, or second to last question, I should say. All right, so we are asked to find theta this time. We want to find theta, okay? So we want to find the angle measure now. So if I want to find the angle measure, I'm given what the, oops, let's go back one. I'm given what the coordinate value is. So if the sine of theta is 1/2, I'm going to have multiple answers here. They need to be between 0 and 360. So somewhere in this circle. So let's circle all the places where sine is 1/2. That means where the y is 1/2. There's one. There's one. And the rest of them are negative 1/2. So where in degrees is the sine of theta 1/2? One of them was 30 degrees. And the other one was 150 degrees. So that's all I got to write. What degree angle, what is theta to make sine into 1/2? Same thing here for cosine equaling 1/2. Where is the cosine positive 1/2? One of them is here, so at 60 degrees. And the other one is here at 300 degrees. So the x-coordinate or the cosine is 1/2 at 60 degrees and 300 degrees. All right, what about tangent of -1? So that means we had to divide sine over cosine to get -1. So in other words, the sine and the cosine have to be the exact same value, but one of them has to be positive and one of them has to be negative. That's the only way this could have happened, is if one of the values was positive and one was negative and they were the exact same. So let's find anywhere where they're the exact same, one positive, one negative. Right there is one of them, so 135. Here, they're both negative, so that would give us a positive one, so that's not it. Here, they are both different and a different sign, but the same number. So our two answers are 135 degrees and 315 degrees. That one's a little tricky. I have a feeling it's going to get a little bit tricky as well for the rest of them. All right, a sine value of rad 3 over 2. Let's take a look. I see one there, and I see one there. The rest of them are negatives. So my 2 degrees are 60 degrees and 120 degrees. All right. Now we've got cosine of theta equals 0. So that means we should have cosine equaling 0. That is right there and right there. Those are the only places where the cosine equals 0. So my only answers have to be 90 and 270. All right, and the cotangent of theta is undefined. So the only way the cotangent is undefined is if the tangent was the reciprocal. So that means the tangent would have to be 0. Tangent of theta equals 0. That's the only way this is possible for the cotangent to be undefined. Where is tangent 0? Well, that is only when the sine is 0, because you can't have 0 on the bottom, because that would make it tangent undefined. We need tangent to be 0 in order for cotangent to be undefined. So we need a y value of 0, which is the sine. So sine of 0 is at 0 degrees. It is also at 180 degrees. And don't forget, it is also at 360. Okay, 0 and 360 are the exact same thing. All right, you also are going to have to do that in radians. It's the same process, but that unit circle is your best friend for the rest of this lesson and probably into the rest of the unit. Okay, so make sure you have that unit circle handy. It helps you with all this stuff. That is it for 9.2. Good luck. Have a great rest of your day.